Okay, this is part two of the multiplying binomials and looking for patterns. So, in getting ready for factoring polynomials. And I think to speed things up, because the last video went kind of long, I'm just going to do a couple, then shut the video off and do a bunch more, and then come back on. So in number 22, as I was saying in the last video, notice that we've been doing binomials with just addition signs, and now we're going to do binomials with just subtraction signs. So we have 2x times 7x is 14x squared. 2x times negative 1 is negative 2x. And negative 6 times 7 is negative 42x. And negative 6 times negative 1 is positive 6. And of course, as always, the middle term adds together, gives me negative 44x plus 6. X times x is x squared. X times negative 7 is negative 7x. And I got to work on my 2's. Negative 3 times x is negative 3x. And negative 3 times negative 7 is positive 21. And as always, the middle terms add together. And okay, so I'm going to pause this for a minute. Recording. So I went through and finished up these binomials, and so if you haven't, you might want to run through and just do them, because I think it's helpful for you to be doing them instead of just looking at what I've done. And again, we're looking for patterns. So we left off up here, and I'm going to pull up my red thing so I can see it clearly. So again, the main pattern is that when you multiply out binomials, you know that usually two of the multiplications are going to give you like terms, and they're going to be added together. So if you follow the FOIL method every time, that, as I've pointed out several times, the first term is going to be first times first, and the last term is going to be last times last, and then the middle terms are the ones that add together. And so we noticed up here in the very first ones we did that the middle terms always canceled out, and that's why we only had two terms. Then we came down here and we noticed that the two terms are the same, or the two binomials are the same, and so the middle term was there, and it was always twice what one of them was, meaning that when I multiply 3x times 4, I get 12x, so the middle term is going to be 24x. Or when here I multiply, not this one up here, when I multiply x times negative 2, I get negative 2x, so it ends up being negative 4x. So then when we got down to this one, the binomials weren't exactly the same anymore. And of course, they still had middle terms that added together. And this is where it gets a little bit tricky, because when we're going factoring, we're going the other way, when we're trying to go back to that, we have to come up with something that multiplies together to give me this, something that multiplies together to give me this, and then it produces these middle terms to give me the 17. Okay? But what we did notice is when there was a plus here and here, we noticed that both the binomials had pluses. And then down here, we had a bunch of minuses. We had a minus in both binomials. I'm sorry, going the other way around. If we have a minus for the middle term and an addition for the last term, that tells me that both of my things are going to be negative. So the thing that I noticed is that when the last term is positive, then the terms are the same. I mean, the binomials have the same sign. Notice here that my last term is positive, and they're both positive. My last term is positive, they're both positive. My last term is positive, they're both positive. My last term is positive, they're not both positive, they're both negative. Last term is positive, they're both negative. Last term is positive, they're both negative. So when the last term of the polynomial is positive, that tells you in factoring that the binomials are going to have the same sign. They're either both positive or both negative. And then when you get down to here, notice here that all of these last terms are negative. Notice that? Negative, 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 negative. And notice that all these binomials have the opposite signs in the middle. So just looking at that third term, whether it's positive or negative, if it's positive, that means the signs are going to be the same. If it's negative, the signs are going to be different. So then when I look back up here, if it's positive, if the last term is positive and the middle term is negative, that means that both my binomials have a negative in them. If the last term is positive and the middle term is positive, that means both my binomials have, or both my factors have positives in them. But then when we get down here, last term is negative. That means that they're going to be different signs, and there's nothing to indicate which one is which. Although you do notice that this is positive because the bigger of these two is positive, right? That's negative because the bigger of these two is negative. That's negative because the bigger of these two is negative. That's negative because the bigger of these two is negative. Positive because the bigger one's positive, etc. So in order to get when you have a negative last term and a positive middle term, that means that you want your bigger term, your bigger of the outer inner to be positive. So those are just recognizing some patterns. So if we keep that in mind, let's grab a couple of these that we've just produced. Like, for example, 10x. Oh, let's start with an easier one. Like, for example, 6x squared plus 5x minus 4. Okay, we know what it is because we've just done it. Let's pretend we don't know, and let's factor it. Okay, so judging from what we just learned from these patterns, we notice that the last term is negative. That means that we're going to have a plus and a minus for sure. Could it be a minus and a plus? Yes, that's fine. But we know they're going to be different. Okay? So then we go to work with, let's figure out the first term. So we know that this times this has to be 6x squared. So my options are 6x times 1x or 3x times 2x. And that's my only options. Likewise over here, this times this has to be 4. So I'm looking for 2 times 2 or 4 times 1. Okay? So now I'm looking for some combination of multiplying my outer and my inner to get the 5x. So if we just take a guess, let's call this 6x and that x. So then we'll just try 2 and 2. So if I put a 2 there and a 2 there, does it work? So that would give me negative 8x, and that would give me positive 2x. Oops. And that does not work. It gives me a difference of 6 instead of 5. Okay. And you can see if we did that, if we just keep doing that, you're going to try, you've got to try 1. If you try this and those 2, that's 2. And then this and those 2, that's 4. You're going to have to try 4 different combinations. And notice if there was more factors, it'd be even worse than that. So we need a shortcut. So what we're doing, the way you want to think about this is, because this is negative, and we know this is the terms in the middle here are positive and negative, then that means I'm looking for a difference of 5. Okay? So I can just real quick in my head say, okay, 6 times 2 is 12, and 1 times 2 is 2. That's not a difference of 5. So I go 3 times 2 is 6, and 2 times 2 is 4. That's not a difference of 5. So we can know that 2 times 2 doesn't work. So then we go 6 times 4 is 24, and 1 times 1 is 1. That's not a difference. Or we could do 6 times 1 is 6, and 1 times 4 is 4. That's not a difference of 5. So we can eliminate that one. Now we go 3 times 4 is 12, and 2 times 1 is 2. That's not a difference of 5. And then finally, 2 times 4 is 8. Of course, the last one we try. 3 times 1 is 3, and that is a difference of 5. So that means that these are the ones we want. So we want 3x here and 2x there. And then we got to put 4 in the right place. We want to get that 8, right? So we'd put the 4 over here, so it's multiplied. Oops, nope. We put the 4 over here, so it's multiplied by 2. And the 1 over there, so it's multiplied by 3. And just to check to make sure, 3x times 2x is 6x squared. 3x plus 1 is 3x. 4 times 2x is 8x. Oh, whoops, I put a plus and a minus, didn't I? I want that plus and that minus. So that'd be negative. And then finally, 4 times 1 is negative 4. Now, how do we know that we wanted a negative there and a positive there? Because remember, the middle term is positive up here. That means we want the biggest term to be positive. So we want the 8 to be positive and the 3 to be negative. Okay? Okay, let's grab another one. Maybe we'll go up here and grab one that we've done that was like 2x squared minus 11x plus 12. 2x squared 2x squared minus 11x plus 12. Hide it real quick before we see the answer. Okay, so we're trying to go back to factoring now. So once again, we go like this, and the first thing we notice is the last term is positive, which means the signs are the same, right? So it has to be negative and negative, because the middle term is negative, okay? So then we write our possibilities. We got 2x and x. That's the only possibility, so I'll just go ahead and put those in, 2x and x. And over here, I got 12 times 1, 6 times 2, 3 times 4, okay? And because their signs are the same, that means I'm looking for a sum. So I'm looking for a sum of 11. And that sum is going to come from multiplying by 2 times something and 1 times something, right? So of course, I'm going to start down here because it's more likely going to be, it's not a very big sum, so I can start with smaller numbers. So 2 times 3 is 6. And 1 times 4 is 4, and that's not quite 11. Let's try the other one. 2 times 4 is 8, and 1 times 3 is 3, and 8 plus 3 is 11. Aha! So that means this is the one we want. And I want to get 8, so that means the 4 has to be there, 3 has to be there, and check just to make sure, 2x times 2x is 2x squared, 2x times negative 4 is negative 8x, negative 3 times x is negative 3x, and negative 3 times negative 4 is positive 12. So we get 2x squared minus 11x plus 12, and it works. Yes. So that is my answer. Okay. Let's grab another one like 6x squared minus x minus 1. Okay. So if we want to factor that thing, we're going to go boom, 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 boom. We notice that it's negative at the end, which means the signs are going to be different, right? So I'll put a plus or minus there to remind me. I might have to switch them around, but we'll put them like that for now. And notice that there's a 1 here, so that means my only option here is 1 and 1. So the options on this side would be 6x and x, and 3x and 2x. And because the signs are different, I'm looking for a difference of 1. Well, it looks like that's right there is what I want, because I'm not going to get a difference of 1 from 6 and 1 by multiplying by 1. That will give me a difference of 1. And notice that the middle term is negative, so I want the bigger term to be negative. So I'm going to put the 3x here. That'll be negative. And the 2x there, that'll be positive. And sure enough, that's right, isn't it? 3x plus 1, 2x. Now notice that this is in a different order than that, which of course is perfectly okay, because the commutative property of multiplication says if I multiply this times that, it's the same thing as multiplying that times this. Okay, let me grab another one like 3x minus 1 times 2x minus 3. Whoops, I wrote the answer down instead of the binomial. Okay, forget that, what we just wrote down, 6x squared minus 11x plus 3. Okay, so once again, we notice that the last term is positive and the middle term is negative, which means they've got to both be negative. So we can just put that in right away. And then we know that this is going to be 6x and x, or 3x and 2x. And over here, I have just 3 and 1 are the only options. Okay, so let's just put 3 and 1 in, because it has to be 3 and 1. And then we're going to look for a sum of 11. Because the signs are the same, we're looking for a sum. Okay? So 3 times 1 is 3, and 1 times 6 is 6. 6 with 3 is 9. That's not going to work, so I can get rid of that one. But now let's do these. 3 times 3 is 9, and 2 times 1 is 2, and sure enough, 2 plus 9 is 11. So I want 3 times 3, so I'm going to put the 3x right there, and I put the 2x right there. There's a train going by my house right now, so you can probably hear that in the background. Okay, so I think I'm going to end this now. To give you an idea, I will produce another video where I'll just be doing a bunch of factoring and looking for these different patterns. All right.